Okay, inequalities. Basically, the thing you need to know about inequalities is that you, whenever you divide or multiply by a negative number, your inequality sign flips. Okay, so that's going to be the big thing that we're going to use. Interval notation is a way of writing the set of all real numbers between two endpoints. The symbols brackets, so this and this are used when we include an endpoint, so when we fill in the endpoint. The symbols parentheses, so left and right parentheses, are used to exclude an endpoint. Okay, so what that means is if I had a number line and I wanted to include the endpoints, I fill in the endpoints. If I didn't want to include the endpoints, I'd have open circles there. So open circles go with parentheses, closed circles go with brackets. Okay. So if I had my number line and I wanted numbers less than 4, let me draw my number lines on each of these. Okay, numbers less than 4, you put 4 anywhere on your number line. You want everything less than it. Would that include 4? No. So you're going to do an open circle, and you're going to have everything on the left of 4. Okay, it starts way down on the left side, so the biggest negative number possible. Right, you never get to the biggest negative number possible, so we write negative infinity. So it starts way down at negative infinity, negative big numbers, and then it goes all the way to 4. We don't include 4, so we do a parenthesis. Oops, that's your interval notation, sorry. Jumping ahead of myself. Negative infinity to negative to 4. All right, as an inequality, you would say numbers less than 4, so it's x is less than 4. So x is some number, and it's less than 4. All right, interval notation, you always read like a book from left to right, and you include all the numbers from left to right. So you start way down at negative infinity, you keep shading until you get to 4. All right, numbers greater than or equal to negative 3. So put negative 3 anywhere on your number line. You want everything greater than or equal to. So since it can be equal to, we fill in negative 3. It's like negative 3 has been part of the shaded line, right? All right, we want everything greater than or equal to negative 3, so it's x is greater than or equal to negative 3. And as I read like a book from left to right, what's the first number you get to? 3, negative 3, right? You include negative 3, so let's do a bracket, negative 3, and then we go all the way forever on the right. So we go to positive infinity. Then I put a parenthesis. And a lot of people always say, well, why do you not do a bracket on the infinity as well? You only put a bracket when you equal that number, and you can never equal infinity. It's like that argument, you know, when you're always fighting with your brother when you're little. I was always like, I hate you times infinity, and he'd be like, I hate you times infinity plus 1. Like, there's never an end to that argument. It just goes on forever, doesn't it? So infinity, you never actually equal infinity. You just keep getting closer and closer. All right, numbers between 1 and 4. So put 1 and 4 on your number line. When it says between, that's a little weird. Usually if I'll put between on the test, I'll say between 1 and 4 not including the endpoints, or between 1 and 4 including the endpoints, so you know. But if it's just between 1 and 4, I would say that you do not include the endpoints. So we're going to do open circles on those. Okay, so the first number you get to is what? 1. So you're going to have parentheses 1. The last number you get to is 4. So that's the interval notation, 1 to 4. That's telling you you include everything between 1 and 4. And what about the inequality? Anybody have any ideas on how to write that? Gabby?
Like 1 is greater than x and less than 4, so like 1 greater than sign x less than sign 4?
Close. It's 1 less than sign x less than 4. I think what you're saying is x is greater than or equal to 1 and x is less than or equal to 4, which is, it's right if you say it that way. But we usually sandwich it right in between. So see how on the left side you have 1 is less than or equal to x. In other words, x is greater than or equal to 1. And then on the right side you have the other one, x is less than or equal to 4. So you have both inequalities.
But it's not greater than or equal to.
Oh, that's right, it's not greater than or equal to, is it? So less than. 1 is less than x is less than 4. Okay, the next one, numbers 1 through 8. So now when I hear 1 through 8, I think I want to include everything through number 8. So I want to include 8. And when I hear 1 through 8, it makes me think, okay, I'm starting at 1 and I'm including everything from 1 all the way through 8. So I'm going to fill in both of those. All right, so this is going to be 1 is less than or equal to x is less than or equal to 8. What's the interval notation going to look like? How about Izzy? What do you think?
Bracket 1, 8, bracket.
Perfect. So bracket 1, 8, bracket. All right, we're going to use interval notation when we solve these inequalities. All right, so graph each set on a number line and use interval notation to represent each set of numbers. So same kind of thing. So you're just kind of practicing the graphing and then interval notation. So it's saying 2 is less than x and x is less than 3. So in other words, x is between 2 and 3. Open circles, right? Because we didn't include 2 and 3. We didn't have less than or equal to. And our interval notation is parentheses 2 to 3, parentheses. Okay, Matthew, what would you do on the next one? What would it look like?
On B.
Yeah, on B.
-3 and the circle filled in, then 4 over there without a circle filled in.
Let's go with Santiago. So what's the interval notation?
Bracket -3 and row in parentheses.
Perfect. All right, Chris, what would you do for the next one? So x is greater than or equal to 4, or it's less than -2.
Circle not filled in, or doing the circle filled in for 4.
And you don't shade between them on this one, right? Because it's x is greater than or equal to 4, so that's on the right. X is less than or equal to 2, so that's on the left. And it can be either of those locations because you had or in between. So it can be the left piece or the right piece. Now this is a little bit harder. If you're writing two separate pieces, you just write interval notation for both of them and leave a little space in between. So the left side is you start at -infinity and you go all the way to -2. And then the right side is bracket 4 to infinity. And then we want to say that this is all one solution. It all goes together. So we do a U in between. Now notice I did the U like that and not like with a stem. It's a mathematical symbol, so U does not have a stem on it. Okay, that's called a union. It stands for or. So when you have or, it's going to be a union. All right, it says, in the above example, we used the word or. You should notice that there were two pieces shaded in the number line. We used the symbol U, called the union, for or statements. Okay, number 2, so use interval notation to represent the set of numbers graphed on the number line below. Okay, so interval notation, so I'm going to start at -4, and I include it. So do a bracket, -4, comma, you go all the way to 2, and that's a parenthesis. because you don't include 2. Okay, the next one has 2 pieces, so I know I'm going to have the union in between them. The left piece is negative 3.5 to negative 2. My shading's not very good. I think that's supposed to be filled in, so go ahead and fill it in. So brackets on both. And then the other one's 0.5 to 2.6, parentheses on both. Okay, making sense so far? We use interval notation throughout Algebra 2, so it's very important that you guys learn how to do interval notation. Okay, C, I have negative of 1, and then it goes to infinity. Okay, so like I said, interval notation we're going to use all the time. Set builder notation we don't use very much. It's kind of the easiest, though. It looks weird when you see it at first, but it's really easy because you can write whatever you want in set builder. So it's a notation for a set that uses a rule to describe the properties of the elements of the set. So the line straight up and down, that line is read such that. So when you see x, the line, and then x is greater than 4, it's read x such that x is greater than 4. So basically any number where it's greater than 4. Okay, so number 1, I have 0, 2, 4, 6, 8, and so on. What kinds of numbers are those? Even, but do I have negative 2, negative 4? So they're even what? Even, you can't say positive because 0 is not really positive or negative. I heard someone say it. Caitlin, did you say it? What is it when you start at 0? You could say even whole numbers. So even whole numbers, so that's one way. So you do your brace. I know you guys love drawing the braces. X such that x is an even whole number. You could say kind of what Gabby was saying. You could say x such that x is even starting at 0. So it's an even number and it starts at 0. Or you could do it really symbolically. And this is the way, like, later on in math people write things this way, but I don't expect you guys to know right away. It's x such that x, well, let me write it a little bit different. So x is even, and then you can say x is an element of. So see that fancy E? It looks like this. That means element of. It's kind of blurry there. I'm having trouble with my little pen here. So x is an element of the whole numbers, right? So we're going to do the fancy W. So it's an even and it's a whole number. So there's lots of different ways you guys could write that. What's another way? You could say x such that x is greater than or equal to 0 and x is even. That's another way. All right, number 2, write the set of numbers negative 3, negative 2, negative 1, 0, 1, 2, 3 using set builder notation. So what do you guys notice about those numbers? What kinds of numbers are they? Integers, right? So x such that x is an integer. Oops. Integer. Or you could say x such that x is an element of, do you guys remember the symbol for integers? It's C. So z. So x is an element of the integers. All right, you guys don't have to use little symbols. You don't have to do that way, but all right. Okay, roster notation we haven't talked about. When you list someone's roster, so if I'm talking about the basketball team and I call out the roster, what am I doing? Yeah, I'm just calling out their names, right? I'm writing the list of not runners, I'm thinking cross country, the list of basketball players, right? All right, so all real numbers except 1. You cannot write that in roster notation because you can't say, okay, I'm going to have 1.1, 1.01, 1.001, 1.0001. You know, you can't list. There's an infinite number there. Okay, interval notation. Interval notation, if you're including everything except 1. Sometimes it's best to think of it on a number line. Basically, you want to fill in everything except at 1. You want an open circle there. So how would you write that in interval notation? So Rebecca, you want to try this one? There's 2 pieces. What's the left piece? Yep, and then what's the right piece? That's it. So you have 2 pieces. So it's negative infinity to 1 and then 1 to infinity. Set builder, like I said, set builder is really the easiest, even though it looks weird. I mean, there's all kinds of things that you would say for this. So what's the best thing to say for this? So x such that I would just say x is not equal to 1, right? So x such that x is not equal to 1. Now, if you wanted to be more precise, I mean, I would assume that you're talking about real numbers. But if you wanted to say x is not equal to 1, x is an element of the reals, that would be more precise. Okay, this is a hard one. Numbers within 3 units of 2. So again, try to draw it out on the number line if you're having trouble. So here's where 2 is. You want to be within 3 units. So go out 1, 2, 3. Go out 1, 2, 3 from both sides. So what numbers are on the ends? Yep, because it's 1, 0, negative 1, right? And then what's the number on the right? 5. You're just subtracting 3 and adding 3. All right, when you hear within, do you think it includes the endpoints or no? I would think no. Yeah, so I do open circles on the ends and include everything there in between. So all those numbers between negative 1 and 5 are within the 3 units of 2. All right, so interval notation would be parentheses, negative 1 to 5, parentheses. Set builder. Oh, I skipped one, didn't I? Set builder is x such that. What's a way of writing everything between negative 1 and 5? Negative 1 is less than x is less than 5. Okay, we'll go back up because I realized I skipped one. All right, I have the numbers 1, 3, 5, 7, and so on. That's roster notation. You have a list. You can tell that list continues forever, but it is a list of numbers. What kinds of numbers are they? Odd. Does it include negative 1, negative 3, negative 5? No? You could say odd natural numbers, odd positive numbers, right? Odd whole numbers, anything like that. All right, so I would say all odd natural numbers. Okay, you can't write that in interval notation because interval notation would basically, like you'd have your number line and you'd only include 1, you'd only include 3. There's no way to do that. So interval notation, you always have to have like some kind of shaded line there, some kind of distance that you're covering an interval. All right, set builder notation, x such that. You could say x is greater than or equal to 1 and odd, or something like that. Or you could say x is odd and natural. So that's why I think that's the easiest one, because there's so many different ways you can write it. So I wrote odd and natural.
Couldn't you not say that, like, x was greater than or equal to 1 because of the same reason you can't write it in interval notation?
Yeah, you couldn't say like x is greater than or equal to. You could if you said that it's natural, because that's saying that you're only hitting the natural numbers. Yep. I see what you're saying. All right, number 4, rewrite each set in the indicated notation. Okay, so what's 4a saying? So let's include some numbers. Does it include -3? No, because it's greater than -3, right? So what's the first number it includes? -2, right? So you're going to have -2, -1, 0, 1, 2, 3, and so on. So what's a way to write that in words, those numbers? How do you write those numbers in words? So I'll say all. You guys sleepy today? About all integers. All integers. You could say greater than -3 or greater than or equal to -2, right? Or you could say all integers starting at -2 and going to infinity. All integers starting at -2, something like that. All right, positive multiples of 10. How do we write that in roster notation? So what are the positive multiples of 10? 10, 20, 30. You guys are sleepy. And so on. Roster notation also uses the braces, but you don't have x such that on the roster. You just list them. All right, all real numbers greater than 2. So set builder is the x such that. If it's greater than 2, I would just say x such that x is what? X greater than 2. Yep, you're already assuming when you write x greater than 2 that it's real numbers. But if you wanted to be more precise, you could say, and x is an element of the reals or something like that. But I would probably leave it like that. Oh, that was a nice phrase. D, all even whole numbers in roster notation. Where do I start? 0, because it's a whole number, right? And then you go 2, 4, 6, and so on.
How do you decide that, like, 0 is even?
0 is even. Yeah, 0 is just not positive or negative. But yeah, it always alternates even, odd, even, odd, even, odd. And we know -1 and 1 are odd, so 0 is even. All right, is that it? Okay, so inequality, a statement that compares two expressions by using the symbols greater than, less than, greater than or equal to, or less than or equal to. Okay, so if you multiply or divide both sides of an inequality by the same positive number, the inequality sign stays the same. So it's best to think of examples. Let's see, -3 is less than 5, right? Well, let me make it 6 so I can do a nicer number. So -3 is less than 6. What if I divide both sides by 3? -3 divided by 3 is -1. 6 divided by 3 is 2. How's the inequality sign go? Less than, right? -1 is less than 2 still. So see how the inequality sign stays the same. You had less than, you still have less than. This was the same. Okay, but let's say we have a negative number. So if you multiply or divide both sides of an inequality by the same negative number, the inequality sign flips. So let's think of an example. I have negative 5 is less than 10, right? Let's say I divide by negative 5. Now I have 1 and negative 2. How are 1 and negative 2 related? 1 is greater than negative 2. So see how you went from less than and then you had to flip it to greater than. Does that make sense? So whenever you divide or multiply by a negative number, you have to flip your inequality sign. Okay. So basically this is exactly the same as if you are solving an equation, except when you divide or multiply by a negative. So number 1, so I have 8y plus 6 is less than 12y minus 18. So you can subtract the 12y over if you want. So I get negative 4y plus 6 is less than negative 18. Subtract the 16 over, so I get, or not the 16, the 6. So I get negative 4y is less than negative 24. Now what? If it was an equation, what's your next step? Divide by negative 4. So I get y is greater than 6. Okay, I always say that's the red flag. You divide by negative 4, so you had to flip the sign, right? So y is greater than 6. Okay, if you're going to graph this on a number line, you put 6 on your number line. You want everything greater than it, so open circle and everything on the right. So in interval notation, it would be parentheses 6 to infinity. Parentheses. Okay, you guys try the next one. So try the next one. All right, so on the next one, so I have a plus 9 is greater than or equal to 4a plus 18. So you can do this 2 different ways. You can get the 4a and you can subtract it over. So when you do that, you'd have negative 4a, negative 4a. So I get negative 3a plus 9 is greater than or equal to 18. Subtract the 9 over, you get negative 3a is greater than or equal to 9. This is when you divide by a negative. So you need a is less than or equal to negative 3. So when you do your interval notation, you have negative 3, you include negative 3, and you do everything on the left, like that. So it's parentheses, negative infinity to negative 3, bracket. So that's your answer. Now if you had done it the other way, if you had subtracted the a over, you guys would end up with negative 3 is greater than or equal to a. That would be your answer in the end. That's the same thing. If you want to do the a first, make sure you put a on the left, and see how the pointy side of the inequality sign is towards the a? Pointy side is going to be towards the a when you flip it around, right? So it's going to look like that. So make sure you get it that way. All right, you good? All right, number 3 is negative b is greater than b minus 7 all over 2. Okay, the first thing I would do is clear the fractions because I don't like to see the over 2 part. So I'm going to multiply both sides by 2. So then I have negative 2b is greater than b minus 7. I'm going to subtract the b over. So I get negative 3b is greater than negative 7. Divide by negative 3. So like I always say, red flag. So you get 7/3. So b is less than 7 over 3. And in Algebra 2, I always like to see the improper fraction. I like to see it like that. I don't like to see it as 2 and 1/3, right? I like to see it that way. So leave it like that. All right, so on your inequality sign, you can draw 7/3. You want everything less than 7/3. So open circle and shade it on the left. So it's negative infinity to 7 over 3, parentheses. And that's your answer. Okay, number 4 looks kind of hard. What can we do to make number 4 a little bit easier? Any ideas? Have you seen the trick where you can clear fractions all at once? It's kind of a nice trick. So if you want to clear fractions, so if I had like 1/2 plus 3/4 equals x over 2, you can multiply through by the common denominator. So if I was going to change all of the denominators, what would you change all of the denominators to? 4. So when you do that, 4 times 1/2 is 2, plus 4 times 3/4, well, 4 times 3/4, the 4's cancel, right? So plus 3 equals 4 times x over 2. What's 4 times x over 2? 4x over 2 or 2x, right? So you've made your equation a lot simpler. So we're going to do the same thing that I just did there up above. So if I was going to change all my denominators and make them the same in number 4, what would you change them all to? 8. So I'm going to multiply every single thing through by 8. Okay, I'm going to write the step kind of in between. So I'm going to have 8 times 3m minus 5 over 8 minus 8 times 4 minus 5m over 4 is greater than 8 times 3 minus 2m over 4. Okay, now think about, oh, I always hate when my screen goes off. Do you guys see that 3 minus 2m over 4? All right, think about what happens to your denominators. 8 and 8 cancel. 8 and 4 reduce, right? What do they reduce to? 2. 8 and 4 reduce to 2, like 8 over 4 is the same as 2. So what I really have here is 3m minus 5 minus 2 times 4 minus 5m is greater than 2 times 3 minus 2m, like that. Okay, does that make sense to everyone? If you're confused, let me know. So basically we cleared all of the denominators. All the denominators are now gone. Okay, now keep solving. So I'm going to have 3m minus 5 minus 8 plus 10m, I distributed my negative 2, is greater than 6 minus 4m. On the left side, I'm going to combine my like terms. I have 3m plus 10m is 13m. Minus 5 minus 8 is negative 13. Is greater than 6 minus 4m. I'm going to add my 4m over so I get 17m on the left. And I'm going to add the 13 over so I get 19. So I end up with m is greater than 19 over 17. So not a very nice number, but it works. So m is greater than 19 over 17. So I'm going to write it here. Okay, on interval notation, that means that you have 19 over 17. You have everything greater than it, so everything on the right of it. So like that. So it's parentheses 19 over 17, comma, infinity. And that's your answer. Okay, that's a tricky one. That would be a bonus type question. So good to know. You'll always have a bonus on your test. So. Okay, Marta has at most $20.50 to spend at a convenience store. She buys a bag of potato chips and a can of soda for $1.55. If gasoline at the store costs $2.35 per gallon, wouldn't that be nice? I need to update my notes, don't I? How many gallons of gasoline can Marta buy for her car to the nearest tenth of a gallon? All right, so what's x going to be? So what should we let x be? Yeah, the number of gallons of gas, right? So each gallon's costing $2.35, so you're going to have $2.35 times x. So basically, if I bought 3 gallons, it'd be 3 times $2.35, right? 10 gallons would be 235 times 10, so 2350. All right, but she also bought some things already. She bought $1.55 worth of chips and soda. Okay, the most she has to spend is $20.50. So what inequality sign should I use? Yeah, x is, or all of this is less than or equal to $20.50. Okay, solve it out. So I'm going to subtract $1.55. All right, divide by 235. What do you get when you divide?
8.0638, so like 8.1.
Yeah. So if we're rounding to the nearest tenth, now is it the most she would be able to get is it 8.1? Be careful on these, it's kind of weird, right? We're going to round to the nearest tenth, but if she goes with 8.1, that's too much, right? So 8.0 gallons is the most she can get.